Hi, everyone. Welcome to another edition of Webinar Wednesday. Today is going to be a bit of a winter topic. Before we get into it, let's just introduce our panel here, and then we'll jump right in. Kieran, do you want to get started?
Sure. Pardon me. My name's Kieran. I'm a safety advisor out of the Saskatoon office. And that's me.
Hey, name's Mike Moore. I'm a safety advisor out of the Saskatoon office. I take care of the Lloydminster, Meadow Lake, Battleford regions as well.
I'm Kara Bildfell, safety advisor out of the Saskatoon office as well, and I handle Melfort, Nipawin, Tisdale region.
All right, and I'm Steve Walber out of the Regina office. I guess the sole Regina participant here today. Rather exciting. We'll just jump right into a couple housekeeping things before we get started. This is a recorded session here, and if you can't make it through the whole webinar today, you'd be welcome to check it out on YouTube at a later event. It's also on our Facebook page where you can watch through there. And I don't know if anybody's ready to go. Let's get started with the webinar here. So I will. Is it showing the way it should be, guys? Yeah?
Yep.
All right. So, yeah, good morning, everyone. As we're in the midpoint of September, we thought it'd be fitting and slightly sad that we are into the topic of winter. The need to heat and hoard will soon be here, and for some it is already. Definitely depending on what part of the province you're in, the freezing temperatures are definitely hitting some more than others. So it's really time to really think about your heating and hoarding, and it's going to be pretty dependent in the construction industry going forward. You know, the purpose, heating and hoarding, probably rather obvious for most, but it's to provide warm, dry work locations. Might be for preserving your equipment and materials, or enable work to be conducted at warmer temperatures, such as curing concrete. When workers are required to work outdoors, maybe you just need to have a place for them to go inside and have their coffee or their lunches. Sometimes it's a matter of material that needs to stay warm while you're waiting for it to be used, or equipment or such. But a wide variety of reasons in the construction industry. So when you're thinking about heating, you got the heating and hoarding side. We're going to talk about heating to start here. When planning for heating, there's plenty of things to consider. You need to know how big your area is that you're going to heat it. You need to what heating demands to achieve the temperature requirements. I mentioned the size, but how long does it need to be heated? Is this for equipment? Is it for workers? Is it for both? Does your heater need to be portable? What's the accessibility to it? You got to think ventilation and air quality, power requirements. You know, whether it be natural gas or propane or diesel lit, you still need that fan to start. So you still need to be close to a power requirement for most of these items. When it comes to the fuel, when you're trying to fill these things up, like, do you need access with a jerry can, or do you need to get a full truck in there? All that sort of stuff. So whenever you're deciding on what you need done, you need to think about all that and much more. You know, so be thinking about WMIS and TDG. A wide variety of things are necessary. So we're just going to get into some common heater types. Now, of course, this isn't the end-all be-all list. I'm just going to quickly go over some of these things, just so we know what they're out there and what they're used. But there's going to be different sizes and shapes and styles for all of this stuff. So it's really, you know, I invite you to you know, talk to the supplier of these units, and then use your manufacturer's instructions to get a better idea of exactly what you need for the job you need. But for all intents and purposes, this is just a quick overview of some of the heater types. Starting with your convection heater, which is just your propane heater. These can be great little sources of heat if you just need to get an area heated relatively quickly, or just get it above that 0 degree temperature. This is one of those ones that doesn't actually need a power source, because it's just basically a heater being fed by propane, like much like a barbecue would be, right? But your main concern with this is the air quality. So you can see in these two cases, they're both inside. So you really have to be having some way to monitor your air quality. And so, keeping windows open is highly recommended. So they're not, if you need something to stay warm for long periods of time, probably not right for you. But if you need something for a quick source of heat, to keep it above there. But again, just really monitor your air quality.
Yeah, Steve,
Yeah.
I've used a lot of these heaters as well, with there being just kind of I don't even know what you call them, some sort of catalytic conversion or something, but there's a lot of gas that's emitted off of these heaters. They try their best to go as clean as possible and burn as clean as possible. I even have I think it's called like a Big Buddy or something like that, and it's designed for ice fishing and indoors and that. But even on the manufacturer says, like, this is not designed for indoors, right? Like, so the manufacturers of these, even though they seem like they're going to be a good option for us inside and that, they aren't necessarily recommending it, because they would be liable then if there was something bad that happened. Like, for example, these heaters are going to work good to maybe take the bite off of something, but they're not going to be designed necessarily to heat. Like either one of these examples, you're not going to heat a whole house off of that little propane heater there, because you'd have to leave it running all the time. You'd have to close up the windows so tight. These are going to be designed where there is some airflow. Basically, probably the only time I've ever used them that worked well was when I would like go and put my hands over top of them just to get to thaw my hands out, or to take the bite out of the air. But you're still going to need ventilation. Therefore, you're going to be bringing cold air in. So there is an application for these, but I think user beware.
No, I won't. Go ahead.
For sure. And on that topic too, you look at where those are placed. You notice the housekeeping is immaculate in these two pictures. So having items nearby that are flammable, combustible, aren't going to be your friend in the situation either.
Kieran, that's a great thing. I was on site one time. It wasn't maybe 2 winters ago, and I went into they had a sea can or it was a reefer body on a trailer, and they used it as the cold storage. And then they quarantined an area off, or sectioned an area off for office space and for guests and stuff. So we were going to do a toolbox talk. We went into there, and I went in with the site supervisor. And as soon as we walked into the trailer, they had one of these little heaters down there, but it was one of those ones that's kind of on the ground with just a flat plate on the front of it. And it radiates heat, right? And they had put their caulking from because caulking from their construction project or whatever, all in front of this thing to keep it, maybe it froze the caulking, or it was just cold and they wanted to warm it up so it spread a lot easier or something. And as we walked in there, one of those caulking tubes out the side of the tube on the top of it, actually, because of the heat that was directly hitting that tube, it burst and was spraying PL Premium all over the element. And it immediately started on fire. The element started on fire. So thank goodness we were there, because he was able to grab the box, move the box out of the way, and then that fire went out immediately. But if that PL would have just kept spraying on that thing, they would have burnt down that trailer, potentially burnt down the house right next to it. Could have been very, very extreme. So absolutely, Karen, fire hazards with any heater, especially these ones, I think is a special circumstance.
And to go one step deeper into it, if we look at what propane is, it's an LPG, which means that it expands rapidly in air. So if there's a leak on that tank you see in the photo on the left, if there's a small leak, it expands at a rate of 240 to 1, like I said. But that means that it's going to be very flammable very quickly, and especially without ventilation, if you do have your windows closed, you're going to be looking at a lower explosive limit relatively soon after that thing starts leaking. So another reason why it is definitely not a great option for an indoor setup.
Or to leave unattended in that case.
Yeah.
So yeah, great points, guys. So basically put, you know, they do have their place if you need, you know, quick sources of heat, but their limitations are, you know, I think were just brought up very well by our panelists here. So let's move on to another heater. Well, actually, no, first, let's talk about another source of propane heat, which is not a heater. I just thought I would add this slide in here to go with the propane heat slides, because anybody that's worked on construction sites before has seen these used as heaters probably at least once in their days, but it's not a heater. They're great sources of heat. They can be a valuable asset on a job site, but they are sometimes misused in a manner that can make them a pretty dangerous piece of equipment. So just remember, source of heat, not a heater. There is a difference. It definitely has its applications, but
talk about a fire hazard.
Yeah.
Let's use an open flame Tiger torch to heat an area. And let me tell you, I've done it like underneath. I used to work in transport truck trailer. Like I'm a welder by trade, but I had this job where I had a mobile truck, and I would service transport truck trailer stuff. So I'd use Tiger torch to get if the brakes froze up, stuff like that. But what we would do in a pinch would be use a pipe underneath a vehicle or something like that, and then you would throw the Tiger torch through the pipe, and then it radiates heat off of that. There's hazards involved with all of that. Like you say, Steve, this is not designed as a heater. You know how much oxygen you're burning up and stuff using an open flame like this. It's extreme caution should be taken anytime a Tiger torch is involved.
Yeah, and you can see, like with most cases, you know, that flame, you know, if you're using it for a source of heat, is most likely going to be next to your tarp or whatever, stuff like that. And, you know, you can call them fire retardant tarps all you want, but it doesn't take long for a Tiger torch to prove that wrong. All right, direct fired heaters. These are, you know, think your gas grill, or oh yeah, sorry, I was looking at the wrong picture there. These are kind of like a gas grill. Basically, the heaters they're great efficiency because they are just burning the air basically around you, heating it really fast. They provide heat by just forcing the air through a gas flame. It's incredibly efficient and allows the device to heat a space quickly. The problem is it's kind of like the propane style system. It's actually would be forcing the CO2 emissions in the same area that it's forcing the heat in there. So it's got its applications. You're still going to want to think ventilation, but if you're just talking needing heat rather quickly, they are great sources of heat, and they do burn way more efficient than an indirect would. Well, I shouldn't say way more, but quite a bit more.
So this exact model, Steve, is this is an open flame, kind of like, it would be like that's a propane model, it looks like, but it would be a direct fire, kind of like a Tiger torch on steroids. Is that what?
Yeah, essentially it would be, well, think kind of in between kind of like that propane style thing, where it's essentially, you can see it, like it's got no exhaust on it. And you'll see the difference when we get to the indirect, because this is basically, yeah, in this case here, you're burning propane, and that propane is heating the forced air, and it's just all shooting. So when this is running, you're going to see flames in the front of this thing.
Yeah.
Right. So essentially speaking is, yeah, the upside is it heats your stuff rather quickly. So in the right applications, in the right settings, you're thinking, okay, this is really going to warm this stuff up rather well. You know, if you have it in a space where you're doing a concrete pour and you want to get the the floor ready or the rebar ready, and you just want to tarp that stuff up rather quick, awesome, right? It's just not the best if you're using workers in there too, right? Yeah. Because if you got to think air ventilation, well, then you right there, you're losing that efficiency that you were trying to gain.
I would say that if you're using this in a confined space with human beings in that confined space, like a hoarding or something like that, where your atmosphere is kind of confined, you would now be a hazardous confined space as a result of adding one of these heaters. For one, another thing too is this is very moist air. Like it comes out and it's very damp. So that's a consideration for your construction project to have that. But I used to have a diesel heater like this. It was running inefficiently. It didn't have a real good burn up or whatever. So when I started it up, there'd be a big poof of smoke that came out of it. This is back in my younger years before I understood air quality the way I do today. But I was using it to heat my garage. And a friend would come over and work in the garage, play darts, all that stuff. And I would use this diesel heater in there. We left that garage with headaches. We would leave just stinking like we went, when you used to go to the bar all night and then you would go home and smell cigarette on your clothes after you wash them 3 times. It was kind of like that with diesel particulate all over me and in my lungs, and I'd be hacking. Incredibly dangerous. Totally not recommended. Probably, took a couple of years off my life. But I learned lots from that about air quality and these heaters, and especially if they're not burning properly, man, you get some bad fumes from them.
Yeah, and you said it. The one thing I caught what you said too was efficiency, right? So again, when you're reading manufacturer's specs, they're talking about when it's most efficient as well. So you have to think like, even when it comes to your indirect and all these ones that we're going to be talking about, it's your efficiency. You might always be burning it at the proper efficiency. But this one here, to summarize, is a great source of really powerful heat, quite efficient, but yeah, definitely not good for enclosed space with workers involved. Now we get to the indirect fired heater. So again, it looks quite similar to the other one. If you notice, the difference on here is this one's got socks. So it allows you to, because that flame's not shooting out the front, it allows you to redirect that heat. You'll notice that what it has on the top here now is a vent, right? So because of its system, basically, rather than sending air through a gas flame like the direct one does, this air is heated as it passes through an enclosed heating element. So this keeps the air cleaner and reduces the amount of CO2 released by the heater, right? So essentially speaking, the heated air is going through those ducts, but the CO2 is going up through the vent up top there, right? So again, that's a major source of heat going up. So always make sure that it's not blowing up into anything. Like these are able to be redirected. So you have seen them inside buildings, but that vent hole up top, even though it might say it burns without the CO2, that's the air that's getting blown in. It still releases CO2 through that vent. So wherever that vent is headed, you would have to make sure that that particular area is, got great airflow. So that's why you usually see them outdoors just like this. I would say this is probably the most common that I've seen in the construction industry, because it's quite versatile. These here are decently portable. They still require a fuel source like the direct one, but if you can get clean air going in, and they're supposed to be a lot drier air as well coming in.
I think they're used most common because they are beautiful compared to the other heaters. Like these are an amazing heater. The no matter what kind of brand you get, when you have this idea that the ignited exhaust does not enter the space you're working. Now the only way is if that exhaust is feeding itself through the fan and then coming in that way. But I've seen these things. I had at a workplace, we had mounted one of these on a trailer, and we trailered this sucker around with us to most of our jobs in the winter. And man, you can kick out some heat. But a lot of these, the cold weather, extreme cold weather, has a hard time starting sometimes. So you'll see these mounted inside of buildings. They'll put them in, and I've seen that where they're inside, and then they extend the exhaust through a port in the tarp or through a piece of wood or whatever to get that outside. The main concern with that is, do you have a leak in your exhaust system? Because if you have a leak in your exhaust system and you're still transporting gases or exhaust into the hoarding or into the building, then that is should be a great concern. But the heat and the air that comes out of these is just beautiful.
Yeah, and like I said, Mike, if you can get them inside and get that, and you can make sure that that vent is going out, then you're recirculating warm air too. Because if you've ever used these things when it's -5 out or when it's -30 out, if they're sitting outside, the air blowing in can make a big difference, because as fast as it's heating, it's going to definitely heat warmer inside than it is outside, because it's recirculating that air. But again, like you alluded to, Mike, you really have to ensure that air quality control. So even with these that burn, all these applications, you should have some sort of air quality procedure in place. Even this here, I'm looking at this picture, and without knowing, is this a completely enclosed area? Like if this building goes all the way around, even with a 4-foot ducting coming out the top here, it might not be able to go any farther than that, right? And just settle in that area on a calm day. So again, air quality no matter what. All right, now we're getting to kind of a radiator dryer system. So this particular system, essentially it's using ground thaw a lot, but the picture that I have on here is how it's adapted to be a heat exchange system on the inside. So again, it's another diesel, propane, or natural gas. It's to warm heat transfer fluid, which is typically glycol, but not necessarily always. Basically, it heats it up. The glycol will go through the hoses, and then it'll transfer the air through those fans that you see on the right that are inside the building. So this is, again, the device outside the building is going to be bad air quality. It's burning gas, right? But the inside element is like running a radiator, right? Where it's essentially just taking that heat from the glycol and pushing it out the fans, and then it just recirculates through. So this can have a multi-purpose thing. So if you have one of these on site and you're doing groundworks outside, and you're doing work inside that you really want to maintain that dry quality, you're going to get it with this particular item. But the downside, you look at how big the hoses are coming inside, right? So they're not quite as portable in that sense. They do have couplers, so you can move them and move that hose around, but those hoses can be fairly heavy. But they are great tools for like bigger options, and like I said, with the versatility of ground thaw as well.
When you take a look at those hoses, there is a potential, especially with where those bricks are. So if you're to drop a brick on a hose like that, who knows if it pinches and it's leaking hot glycol at the same time. So putting the hoses in a more logical place than right beside a giant pile of bricks might also fare well for you.
Yeah, no, good point. Like it's
any other rupturing hazards, I guess.
Yeah, no, for sure. Like that is a pressurized glycol going through those lines. It's quite thick, but again, it's like anything else. Like any electrical cord or any item you have coming into a construction site is designed to be for a construction site, hopefully, but it still has its limitations when it comes to safety, and should be hung out of the way as a housekeeping item. All right. Next, we have the flameless heater. So this the basic idea of this is think of it as burning like a piston engine on the inside, right? So it's using it operates by using diesel fuel to agitate like a hydraulic oil into a flameless, sparkless, low pressure environment. The combustion in a flameless heater takes place entirely within the confines of the combustion chamber, similar to a reciprocating piston engine. And because of that, you're not going to have maybe the same worries of that open flame that you might have on job sites. I would say in the essence of your CO2 worries, it's the same as the indirect, right? It's meant to heat the air outside, and then it's pushing clean air inside, right? Probably even more efficiently. But as you can see, still has an exhaust on the outside because it's still, to get that air burning, it uses a different way of heating that air without having to use actual flames, but it still requires the burning of, diesel or natural gas to get the job done. So again, the warm air that you are using, it should be nice and clean, but you still need to have in an area that's well ventilated. Okay, and then, last but not least here, for at least the ones we're talking about today, is just the electric space heaters, for those inside jobs, probably the most common used, most homeowners have an electric space heater. You see the ones here are definitely bigger for construction. Again, they're not all just regular 110 volt or anything like that. These ones here, like the one on the right, you would need to be plugging into where you would plug in your dryer in your house or your stove. That sort of kind of power is what it would take to keep that thing going. But they can warm up a room pretty. If you've got the right power source and you're at that stage in construction, they're a great alternative. Like that's. I definitely know on the construction sites we worked on, this is what we highly tried to achieve as soon as you could in the winter time, was to get off of those power sources that were, could be bulky, and get them down to where you can just regulate per room with just, the safety of a plug-in. And that they worked really well. But again, you need enough power going throughout your building or your workstation to make this work. All right, now that's pretty much it for heaters. Just can't stress enough that they come they come in a variety of shapes, sizes, types, you name it. We just feel like we just kind of touched the tip of the iceberg when it comes to your choices. But with any construction equipment that you're going to see, you got to follow those manufacturer's instructions. And if you look at them prior to even maybe renting it or getting one, that the limitations of that heater may affect your choice of what you're actually going to bring to site. So it's not a bad idea to do a little bit of research prior to, right? Because you buy something, then you bring it, and then you try to rig it to make it work when that's not the way it should be. You should just get the device that works for you.
So, Steve, on that, speaking of manufacturers' recommendations and stuff, I have seen in numerous places where in the building construction of homes, for example, where a furnace is a temporary furnace is installed. So they would get their gas worker to plumb it in. And also the electrical worker would bring some temporary power there or whatever. And they would hang a furnace from the roof in the basement and use that. But there is some hazards involved in that. And I don't know, I'm going to kind of leave it up to the experts on, what's spec and what's okay and what's not. But definitely having something hung from the ceiling with rigid pipe on it for exhaust or things like that, there is room for errors. So even if it is in spec or you're doing it within manufacturer spec, I think it's still important to every day inspect these temporary heating solutions and make sure that everything is still copacetic, you know, that it was how it was installed, when it was installed, the way it was installed is still that same way. Day 2, day 3, after the people were working the basement or the concrete people were down there working or whatever, and they bang it around or hit it with the power trowel or whatever happens, that through a good inspection process, it's maintaining that original kind of installation quality.
No, that's absolutely correct. Like any of the ones that we have in here, whether it be the types that we showed you, or like you said, Mike, the furnace ones you hang up, that everyone has a limitation and a benefit to it, and it's what works best for you. You know, you talked about the hanging that furnace one up, but you also talked about how it needed somebody certified to put that together, right? So, you know, when it's time to take it down, you need that certified person, and that could be the same for even the ones that we talked about here. Like every one of these requires a propane attachment, so you really got to make sure that you're not just following the manufacturer's specs, but you're following like local bylaws and you know, certification codes and your legislation, because if you disconnect certain types of propane or certain types of connections, you actually need to be certified to do that, right? So you really have to make sure when it comes to that stuff, you know, do you have somebody qualified to do it? Like on bigger construction sites, and you know, when you have plumbers working in that area, you have access to those that type of certification, and it kind of works out that well. But maybe you don't necessarily have that. So if you've got something that needs to move from one place to the other and it looks portable but requires connection disconnection, you really want to be considering that stuff. That might make the difference between like a diesel fed one and a propane fed one, or any of those items. So really take a look at what you got, but those like you said, Mike, you know, certification and competent to run these machines. And you know, you run these things overnight and they melt, and that even ground isn't so even the next day. That heater can be sitting in a puddle. So you have to be aware of not just the conditions at the time you start the machine, but what the conditions will be like once everything's warmed up.
Yeah, and there's that air quality piece is such an important thing. It's good to rely on our sniffer, but like carbon monoxide, for example, is an odorless gas that displaces oxygen. So a lot of times we can't rely on our sniffer, and a lot of times too we do, but we get used to the smell, so we don't even smell it anymore. I had a friend that does concrete, and he was using a power trowel in a basement one time, and that's got a combustible engine on the power trowel in a basement of a house. And he told me how he had to crawl out of the basement because he just got used to the fumes, thought nothing of it, was down there working. And by the time he was done, he didn't realize that, because the effects are like, kind of like you're not making proper decisions, you're not doing that stuff. So by the time he decided to go outside, he was crawling up the stairs. And that exact thing can happen with heaters if it's affecting your air quality.
Yeah. No, good point, Mike.
There's
All right, go ahead, Kara.
On a more recreational note, there's definitely been lots of stories of people ice fishing with artificial heaters that passed out and then passed away because the air quality was so poor. So it didn't take long.
Yeah, and we were actually I was talking with Mike before this even started, and we're like, I told him I'm sensitive to fumes and stuff like that. So when I walk into an area where it's happening, I smell it instantly, right? And I think a lot of people do, but in an area where it starts with clean air and then slowly filters into bad air, and you know, I'm just as susceptible as to anybody. You don't pick up the smell right away, like it's when you come into it. But if you're in it when it's clean and then it slowly becomes unclean, yeah, you have the symptoms before you realize what's happening, right? And you know,
so how do we avoid that? That's the thing. So we want to use, there's construction sites out there, we want to use a furnace inside, or we want to use a diesel heater inside, or we want to, you know, we want to use whatever heater it is. But if it can affect air quality, I think the only responsible thing to do is going to be to monitor that air. Now, whether you have carbon monoxide monitors on site, whether you have whatever you have for a device, which is highly recommended, I would say that it would be somewhat irresponsible not to, or it could be. In the end, if someone died, let me tell you, it was irresponsible. So whether you think it is or not is fine, but if someone did die or someone has major complications, at that point it is absolutely deemed irresponsible. So, and then realizing that whatever monitor we have or whatever device we have to monitor our air to make sure that we're within acceptable limits of breathable air, that it actually tests for the hazards that are involved in that. In this, like you wouldn't test for H2S necessarily when I got a furnace hanging in the basement. So you got to make sure you use the right tester as well.
That's absolutely correct.
As well as the right testing method, right? So if we're a worker and we're using carbon monoxide detectors and they're in the basement and we're working upstairs, versus the opposite's true. If you have monoxide detectors on the first level, you go into the basement, since it's a low-lying gas, you're going to want to have different monitoring systems like personal monitoring, right? So you're going to want to have it right by where the person breathes. So it's actually a telltale sign of, are we monitoring for the right thing, like Mike said? So there's so many different things that go into it. And like Mike said, in the eyes of the law, you're not fulfilling your due diligence if you don't take every reasonable precaution. And then that further goes into 217.1 of the criminal code of negligence, and you can be charged. So the responsible thing is to absolutely monitor the air or choose a different system.
No, great points, guys. Now we're going to talk about another hazard. The air quality is probably the most common, but without the proper maintenance and monitoring, fire is another big one with any heat source, right? So again, alluding to monitoring your equipment, everything can be set up perfect, and then something happens and your direct fire heater turns, or your propane heater tips, or you know, and all it takes is just a quick yank on a hose, right? You just didn't think was going by it. There's so many different ways that didn't look like a hazard until they are, right? So, and again, when you're changing your environment, which you are doing when you're heating stuff, you're changing your hazards pretty quickly. You're going to be going from frozen ground to wet, muddy ground, soft ground, like hard ground to soft ground. And these are all ways for your heater to shift, right? And your heater, even if it just shifts, maybe it's not the heat, maybe it's the air intake, all of that. So again, legislation requires fire extinguishers beside, or shouldn't say beside, but within 9 meters of your ignition sources. So, and you know, it just should be. You don't want them right beside. You want to be able to grab it to put it out, but you do want it around. Another good suggestion, you know, being wintertime and stuff, keep them in like a wooden box off the ground. You know, you don't want that. It's like your fire extinguishers should be not only known where they are, but you don't want them to be like all stuck because they've been sitting outside waiting for you to need it, where it snows on it, then it melts, and then it freezes, and then next thing you know, it's a big ice cube or it's frozen into the ground. So keep them protected. They're an important tool. You might not use them often, but when you do, you really need it. So
they need to be easily accessible.
Yeah, and signage to where they are, right? All right, I think that covers heating. Well, we'll be talking about it more into the rest of this, but we're going to incorporate hoarding into this as well. So again, sometimes, you know, generally when you think winter, the two are combined, not necessarily, right? Sometimes that the hoarding is simply to keep the snow off the ground, or, you know, keep your material from turning to ice, right? It could be used for a variety of reasons. So again, when you're planning for hoardings, you want to consider what your purpose is, your requirements for your location, you know, what needs to be hoarded, what materials you're going to need. You need scaffolding, you just need wood, tarps, like insulated tarps, what type of fasteners, right? And then you got to think, like, do I want this solid, or do I got to have airflow going through it? Number of workers, you know, and then your hoarding, and then with all that, everything being done, your hoarding is still going to require inspection to monitor for snow and ice buildup when that happens, for like shifting scaffolds, or many of the other things that can go wrong, like we'd mentioned with the heaters. All right, so now I'm just going to show some pictures here, guys, and I just invite you to tell me what you see, if you've experienced any construction like this. Right, so clearly they're getting ready to hoard in below this scaffolding here. Potential hazards that I see off the gate is like, I don't see the base plates to the ground here. So if this is hoarding just to keep snow out, it might be fine. But if you're going to start heating inside there, the potential for the ground to shift below the scaffolding is there, right? So again, I'm looking at height that these guys are working at, sort of thing, a little bit too. So
yeah, so they might be doing some brickwork on the side of that building as well. It does look like they have some arch frame scaffolding there that that bricklayers typically use, so they can get wheelbarrows between them, and that. So let's say they're doing some brick. I got a little bit of information here about mortar and brickwork, basically, and at what temperature do you need to do it, because you can't just go and do this stuff at -20. The quality of your end product is going to be so low. If mortar does freeze, if you're doing some brickwork and the mortar actually freezes, it's not going to be weather resistant or watertight, and that's huge if on the exterior of buildings, obviously. The ideal temperature for placing and curing mortar is actually 21 degrees Celsius. Mortar material, like bricks and etc., may be needed to be heated up. So they may have to store that stuff in this hoarding to take that frost out of the material. So when you put your mortar on there, it's actually going to adhere to it. If you use frozen material and you put that mortar in there and stuff like that, this can affect your strength of your joints as well. So, and then the curing process, one of the recommendations that I looked up and have found was actually +4 for 24 hours. It needs to maintain like a +4 temperature for 24 hours. Now, we're already in September here. What was it, last week or 2 weeks ago? -7 overnight, right? So we're already looking at hoarding in temperatures that we're still seeing daytime highs. We can get daytime highs of 20. But then 2 days later, we're hitting -7, you know what I mean? And then for grouts, when you're using grouts, you're going to need that +4 temperature for 24 to 48 hours. Now, lots of considerations for heating in this, when we're considering doing this kind of work. So.
Yeah, no, those are good points. It's not just as you're doing the job. It's the duration before and after. You know, you're going to want to start, you're talking with the grouting and stuff like that. You're going to have your pile of sand, your bags of grout. You're going to need water. All these elements can't be completely frozen when you start. Then you're going to do it, and then you're going to apply it. And now you got 48 hours up to 48 hours, like you said, Mike, at 4 degrees or more. So, you know, where there's the temperature is 0, it's 4 degrees, right? And like on a night that it gets down to -7, how many hours in the day are actually 4 degrees or better? So maybe enough to get the job done, but not enough for your job to be successful, right?
So one of my first investments, if I was a bricklayer or doing stucco or any of that, making my living in Saskatchewan on an exterior job, right, where most of my work is outside, and winter is 6, 7, 8 months long, depending on what temperature we're looking at winter being, would be a good heater, so that I have it possibly hooked up to a thermostat that I can put inside. And so that when I leave the work site at the end of the day, I'm confident that I have the right heating source to maintain that temperature. Yeah.
No, that the thermostat's actually a good point, and you see that even on like those heaters that the Indirects and the Directs and all those, they have that capability where you can connect to them and then, you know, fire that cord right inside the building. So you're not burning, because you don't want it to get too hot either. Like, you don't want this stuff drying out. Like, there actually is, you know, we talked about cold here, but if it's just hovering at that -4 degrees out or +4 degrees, it's not going to take long for it to get absolutely scorching hot inside there. You know, I've seen it where, you know, we've used these inside a building to do drywall and stuff like that, and it gets so deathly hot inside there that the drywall just, like the plaster just cures so fast, everything cracks. Like, it just became useless. So there's that end of it too. So that's where, you know, good point, Mike, on the thermostat. All right, next picture here. I don't know if you guys noticed the little before in the corner here. So we're just going to kind of take a look at a couple of these pictures here. You know, I'm sure they're feeling pretty proud. They're getting ready for their pour. They got a nice tent up here. You know, everything's ready, and it's just going to look like things are going to go rather well, right? Now, outside, same thing. Like, can be looking in some stages really well put together. You know, if it's a nice calm day, it can be under the right circumstances, which is what they had to put these tarps up. Great. But this is what happens when the circumstances aren't quite right, is this third picture. This actually this actually happened during a concrete pour. It wasn't like they got it up, thought we can order concrete. No, this happened when a pump truck and 3 concrete trucks were on site, right? So those first 2 pictures, everything looks ready to go. Conditions were right for, I think we can all agree that tarp didn't get put up in a half a day, right? So conditions had to be right for a decent duration of time. But when you completely enclose tarps, you know, and we'll allude to that, we're alluding maybe more to what scaffolding coming up too, but all of a sudden you just completely change your air pressure. So a little bit of wind on the outside and it gets inside, and the uplift, yeah, you just ran into some issues here. So and then
concrete's like an emergency type of job anyway. It's like go, oh my gosh, trucks are coming, concrete's curing, what's going on? Like, this should be on jeopardy as like, what is worst day at work ever? Because like, I can't imagine having half that concrete poured or any of that concrete poured and this happening to the enclosure. Like the panic that must have been going on that site would have been, and then also your finished product is going to be affected.
Oh, yeah, no, absolutely. Yeah, you know, you alluded to the, I don't know if you have any stats on concrete, Mike, like you did on mortar there, but, you know, let's face it, your minus temperatures out there, you're still going to have your curing issues. And yeah, those trucks getting sent back, and whatever concrete got poured, you're going to be doing your best to dig out of there because you're not ready anymore. So just, yeah, it can be stressful. I remember the concrete pouring days being, I always used to, in framing, consider the crane days to be, but when, you know, I moved to the project management a little bit, it turned into concrete because those could be big days. So you just have to be able to look at all aspects. Yeah, next. So just some more Just another picture of mortar going on here and bricklaying. Does anything stick out for you guys on this picture?
Just when I rammed my knee on that pile of rubble.
Yeah, well, for me, that's actually that's kind of what I saw too, Mike, was the rubble, right? So like you're in instances when you're thinking heating and hoarding, you're first, well, I got to keep the heat in, right? When you keep all the heat in, you're also keeping everything else in to keep it efficient, right? So I think about your material, like what do you do with the material you don't need or the material you took down? So that you can build up pretty fast because you need to have your new material in there. You haven't necessarily taken down the old material if you're renovating, that sort of stuff. But the first thing you want to do is get it heated off and warmed, and then all of a sudden it's like, oh well, geez, how do I deal with my housekeeping and those sort of items? So that's what I saw too, Mike.
Yeah, absolutely. But then you take a second look at it and you can barely see in the shadows. So we take a look at lighting. Another important thing, if we're walking around and there's all this rubble and debris and stuff and pails everywhere, we're going to have a harder time seeing them, especially when we're working. Or if we come in from the bright outside and it's very dark inside, you're not going to be able to see well at all again. So falling, tripping hazards, you name it, lighting will not help if it's like this.
Yeah, I don't want to talk about it, but that's a really good point. But I want to talk about the scaffolding and the overhang of those boards either. Because you stack some material on those boards and take the material off the inside of the scaffolding, and those boards are coming over.
Yeah, really good points, guys. Like in that, and going back to lighting, Kieran, that this is even during the day, and by the time it's cold out, you also have way less hours of daylight, right? So the lighting is suspect at best when you can tell that there's daylight on the outside, but that lighting doesn't even get to that level till what time in the morning now? Or like we're already shrinking our hours, right? And we still want to get that full day worth of work in. So in order to do that, you should be hanging lights inside whenever you are blocking sunlight off. But especially in the winter when you definitely need that more daylight going on, is definitely another hidden hazard that we got to remember. All right, here we're looking at a fully hoarded building. Now, there was no snow on the outside of this building. I just thought this was a good representation of completely enclosing building off, right? So, we have definite presentations on all things scaffolding, so I don't want to maybe necessarily address all things scaffolding and the certifications and stuff that you need in regards to that. But the extra element of adding hoarding to it, right? That's when you got to think about more bracing, and just going back to that other picture that we had with the uplift. Well, there's definitely going to be a different air pressure inside of here, right? So you definitely need to increase your awareness as to what your hazards might be when you start putting essentially a kite strapped to the side of your scaffolding, which was a precarious business at best already. So, and this is what happens if you don't, right? So, it's already 12:56, so this might be actually where we end off here, guys. Just as kind of maybe the don't sort of thing on here. Just a little piece of legislation in regards to this particular. It's not just us talking here. It's where a scaffold is partially or fully enclosed, an employer or contractor shall ensure that all scaffold components and tie-ins are adequate to support the added load that may be placed on scaffold as a result of wind or other adverse weather conditions. Now those other, like wind can seem fairly obvious, but other adverse weather conditions, you guys got any come to your mind? Really?
Fascinated by this picture.
Yeah, it is. So when I think of other adverse conditions in the wintertime, you know, you might not think snow load on the sides of it, but you could get it on the top. Where you can think is over time is if the snow is on top or it's in that melting phase sort of thing, and then it drips down like icicles on the side, right? Or, you know, the inside, you know, if this is depending on your planking, we talked about that before, where it's all of a sudden it's a lot warmer on the inside. And if you're not monitoring those legs, just making sure that they're being adjusted, or that you never made those preparations for a warmer ground afterwards, these are all reasons that could to have it. And then again, just when it says shall ensure that all tines are adequate, right? So that's how do you know it's adequate? You really got to take into all that extra consideration other than wind.
Yeah, they didn't have a large enough control zone around their work area to accommodate the removal of scaffold.
Yeah. Anyway, I don't. We're looking at 1 o'clock here, team. So, does anybody have any closing thoughts that they would like to talk about here? We actually are. I had about 42 slides today to talk about, and we're only at 21. So there's definitely lots of items in regards to heating and hoarding. You know, and this is even just one tiny aspect of winter hazards, right? And you know, we just we didn't even get off the topic of heating and hoarding. So
yeah, I think that this, I would like to say, if anyone watches this video and they've had some experience with, you know, things that have gone wrong or things that go right or whatever with heating, hoarding, with heaters or experience of that, please like and comment in the section below, and so that we can share that experience with our members.
no, absolutely. Like the near misses, whether they're within your company or you're willing to share them throughout the industry, are very valuable pieces of information. So whether it's been an actual accident or a near miss or whatever, this or any other thing, any willingness to share and help the industry grow as a safety network would be highly welcomed for sure. All right, well, I think that wraps up today's webinar Wednesday. So I thank you, team, for joining me here today, and I thought it went rather well. So take care.